Hey everyone, welcome back. In this video, we'll be discussing about the third problem of today's weekly contest. Select cells in a grid with maximum score. The problem is a bit difficult, so I would assume that you know basic equation before moving forward because I might be skipping over some of the obvious dry run for the equation so that the video length can be uh, reasonable. So with that, let's get started. The problem states that you're given a 2D matrix grid consisting of positive integers. You have to select one or more cells from the matrix such that the following condition is satisfied. The first condition is no two selected cell should be in the same row. And second condition is the value in the set of selected cells should be unique. Now, the score would be the sum of the cells that you have selected, and your task is to maximize the score that you can have. So let's take an example. Let's say this is a grid. Now, one of the ways to select the cells is the one to select the red cells from here 1, 4, and 3. And you can see if you select the red cells, you will be satisfying both the conditions given. First condition is you have not selected two cells in any of this row in the same row, and similarly the values that you have selected are unique among each other. So 1, 4, and 3 are unique. So for this selection, the sum or the score that you have is 1 plus 4 plus 3, which is 8. Similarly, there are various other ways to select the cells with different score, but you will not be able to get a score of greater than 8, and hence the answer here is 8. So hope the problem statement is clear. Now, what is the brute force way to solve this? The brute force way could be, okay, I will exactly simulate the problem statement and then figure out what is the maximum score that I can have, right? For example, in this scenario, what you can say is you need to select one cell from the you need to select at max one cell from a given row. So for every row, I will simply check what cell to select, or rather whether to select a cell or not at all. So at every row, either I will select one cell or zero cell, and I will ensure that whatever cell I am selecting is not the value that value is not selected before. And if I can ensure these two, I can and I iterate over all possible combinations, I will get the best answer that I can have. So in this scenario, what you can say is, okay, I will select 5 from the first row. Now once you have selected 5, you can maintain that 5 with you. Now you can go to row 2 and say, okay, I can either select one cell or I can select no cell at all. So if I want to select a cell, this 5 is something which I can't select because I have already selected 5 before. So assume that you said that, okay, I will select 8 from this particular row. Now in that case, you can go forward and say, okay, at row 3 I will either select a cell or I will not select any cell. If I select a cell, I can not select 5 and 8 because 5 and 8 are something which are already selected. So I will either select 3, 1, or 9, or I will not select anything else. So in this scenario, let's assume that you decided not to select anything, so you move forward. And on the row 4, again, you will ask the same question. I can either select one cell or I will not select any cell. And if I select one cell, I can't have 5 and 8 because 5 and 8 are already present. So among the others one, you can either select a cell and write it here and move forward. So once you have decided what to do with each of the row, you can simply sum this up and that will give you the score for this particular combination. You can try out other combinations and the maximum one will be your answer. So what this is all good because you're doing it in a with a pen and paper, but how we will exactly code this out? So coding this out iteratively could be difficult, so you can code this thing easily with recursion. Now can you see the recursion here? I would encourage you to pause and think for a moment. So think about it, what you are being asked for. You are being asked for, okay, what is the maximum sum that I can have if I select either one cell or zero cell from every row here, right? So that is your question. Now initially you said, okay, for the first row at least, I have different choices. I can either select 2, 4, 7, 5, 9, or 8. Let's assume that you selected 5. So after that, what your question is now? The question is, from this matrix, I need to select one cell or zeros, like at max one cell from each of the row, such that the total sum is maximum possible. Plus, I should not select 5 anymore. Isn't this problem equal to the original problem itself? Because in the original problem, we were asked what is the maximum score that you can have from all, like by selecting at max one cell from each of the row. Now, in this problem as well, you are being asked what is the maximum score by selecting at max one cell from each of the row. The only change is you can't select 5 here. Now let's just do one more iteration. Let's say you at second row you decided to have 8, right? Now what is the question? The question is, okay, from this cell, or I need to select one row from at max one cell from each of the row, and give me what is the maximum possible score possible, and I should not have 5 and 8 anymore. So this problem is exactly equal to the previous problem, and you can model the first problem as well in the similar fashion. So if you think about it, this is how your recursive state would look like. Basically, for each, you are saying that after a particular row, I need to fill everything below that row and find out what is the maximum possible score. The only constraint is I can't select some of the values which is there in this array. So if I maintain this row and array and I keep on iterating forward, I can basically, for any state, I can model this state into a set of lower states of same kinds, and that's exactly what recursion is, right? So if you do a small dry run, this is how it would look like. Basically, you will start with f of 0 comma empty array. You are saying that I need to fill everything after row 0, or I need to select at max one cell after row 0 for each of the row, and I need to ensure that I don't select anything which is there in this array, right? So at this state, you can either select a cell or not select any cell. So if you don't select any cell, this is how your state would be. You are saying that I haven't selected any cell at row 0. So give me what is the maximum score possible starting at row 1, assuming that I can't have the elements that is present in this array. Now, second case could be you selected 2 here. If you selected 2 here, you can't select 2 anymore, so you push 2 in your array, and you're saying that, okay, give me what is the maximum sum possible for the rest of the cells, for the rest of the matrix, that is the matrix starting at row 1, and whatever is the best possible answer I can have, I will simply add 2 to it, and that will be my total possible score for this particular state, or one of the total possible score for this particular state. Similarly, if you decided to not take 2, rather take 4, this is how your total possible score would change. Again, same thing. Give me what is the maximum possible score starting at row 1, and ensure that I don't take 4 anymore, right? And this is like all your different state possible, and among all your different possible score, you can take the maximum across all of them, and that will be your answer for f of 0 comma empty array. Let's just expand one more thing for simplicity. So if you have this, which basically means you have selected 5 in the first row, and you're saying that I need to fill the rest of the rows, assuming that I don't select 5 anymore. So in that case, you at row 2, again, you can basically, this problem f of 1 comma 5 is an independent problem, and you can solve it in exactly same way. What is the way? The way is you decide what to do with the row 2 and then defer it further to the same function. So for row 2, again, there are two choices. Either you will take something or you will not take anything. If you don't take anything, this is what your problem would be. Basically, you are saying that I need to fill everything after row 2. Give me what is the maximum possible score, and ensure that I don't take 5 anymore, right? Because 5 is something that I've already taken. Similarly, if you decide to take something here, let's say you decide to take 8 here, then this is your total possible score for taking 8 and filling everything afterward, ensuring that 5 and 8 are not occurring again. Similarly, if you take 1, note that you can't take 5 here because 5 is something that's already there. So you, by definition, you can't take 5. So next time you will start with 1, and this is your one of the possible scores as well. And again, you can take maximum across all of them, and that will be your value for f of 1 comma 5. You will sum it up with 5, and that will be one of the values of f of 0 comma and you can do max across all of them to get the final value of f of 0 comma empty array. So this is how you will code this brute force solution. Now let's look at the pseudocode. Again, you can write the pseudocode in two different fashion depending on how you are maintaining this array. You can either maintain this array in raw format, that is like this format itself, 5 and 1 are already taken, or second way to maintain this array could be a boolean array. Now why these are the two different ways and why these matter? Because those two have different complexity. So I encourage you to write the pseudocode in both the fashion and see what is the time complexity in both the scenarios. So this is how the pseudocode would look like in both the scenarios. One where we are maintaining the raw array itself, whatever we have taken we have maintained simply here. So in this case the sample taken array could look like 1 comma 5 comma 8 or something of that sort, right? And similarly you can have a if taken or a boolean array, and where each value denotes the index, where each index denotes the value, and if it is 1 it means that 3 is already taken and you can't take 3 anymore. Similarly, if it is 0 it means it's not already taken and you can take it further if needed. So what, like, both the problem, like both the ways are exactly similar. The only difference lies in how you are ensuring that a particular element is taken and you are not taking it again. So this is the only statement that differs. The rest of the things are exactly equal. So what we are doing, we are simply checking whether this state is something we have already computed. If we have, we'll simply return whatever was the value before. If not, we'll compute the state. How to compute the state? Either I will not take anything here and move forward, or I will try to take one of the values from this column which is not present in the taken array. If it is present, I will not take it, I will simply continue. So what is the overall time complexity? Time complexity would be number of states multiplied by what we are doing inside the state, because each state is computed exactly once because of this DP array. So how many states are there, or rather what we are doing inside the state? We are doing a for loop which can run up to order c time, right? And inside the for loop we are checking whether the value is something that we have already taken or not from this taken array. The taken array can be of the length r, so this can go of order r in worst case. So this is your time complexity for a single state. Now how many different state could be there? Number of different values of row which could be r, and number of different values of taken. So taken is an array, so you can have anything between 1 and 100 here, right? Why 100? Because the max value that you have is 100. So you can have anything between 1 and 100. Similarly, you can have anything between 1 and 100 here, and so on and so forth. So this can have 100 different values, this can have 100 different values, this can have 100 different values, and so on and so forth. So overall, this array of size 5 could have 100 power 5 different values in worst case. In other words, you can write it as x power r, where x is the maximum value that you can have for any of the cell, and r is the number of rows because you are doing this for every row. So overall complexity would be r cross c multiplied by r cross x power r, right? Let's try to figure out the complexity for this state as well. Everything will still remain the same. Number of state multiplied by number of what we are doing inside the state. inside each of the state, this time we are doing simply order C operation because this lookup is order 1, right? So inside each of the state we are doing order C operation. How many states are there? Number of different values of rows, which is R. Number of different values of is taken, which is 2 power R, 2 power X. Why 2 power X? Because each state here could have either 0 or 1, and this array length could be of X because the max value is X. So the total time complexity would be R cross C cross 2 power X. Now, depending on what's the value of X and R, either this could be better or this could be better. In the scenario, I think this is better because X is 100 and R is 10. So if you think about it, this is 2 power 100, but this X power R would be somewhere around 2 power 70 or 65 or something, right? So this is definitely better than this one in this scenario, but both are equally bad because even 2 power 60 or 70 is not something you can fit within the time constraint. So you need to optimize this. In other words, you need to remove this taken array, or you can altogether, because irrespective of the form in which you are maintaining this, it's something that's not feasible for the given time constraint. In other words, what your goal now is to remove this taken array altogether. So we'll come to this in a bit. So let's try to understand why this taken array is something we considered in the first place. We took taken array because we wanted to ensure that the value in the set of selected cells is unique. So because we want to ensure that everything is unique, we maintain what all we have selected, so that the next time we select something, we ensure that it is not equal to any of the value that we have already selected. So if you want to remove this but still maintain this criteria of the value should be unique, only way is the array is sorted and you maintain a value some X or let's say Y instead of maintaining all the values here. Because if the array is sorted, you don't need to maintain this entire array. You can simply say 7 is the last value that I have seen. So whatever you pick, if it is greater than 7, I don't care, because if it's greater than 7, it will not collide with anything before, because everything before is less than equals to 7, right? So that's the only way you can maintain the inequality and also avoid this array. But for this to happen, the array should be sorted. In other words, what you are taking from the rows should be sorted. But is that practical? Answer is no, because in this scenario as well, you can see if you select 4 from here, no matter what you do from the rest of the rows, you will not be able to achieve the best possible result, because 7 is only there in the first row, and because 7 is only there in the first row, you have to select 7 because 7 is one of the 5 largest element in this entire matrix. So because you have to select 7, you have to have 7 here and you can have smaller values afterwards. So basically you can't have this sorted array by design, but you need to have sorted array because otherwise you need to maintain this entire values with you. So the only way is you maintain the sorted array but give up on the fact that you will fill up the rows in sequential order. Rather, you are saying that, okay, I will fill up that row first from which I need to pick 4, and then I will fill up that row which I have to pick 5, and then I will fill up that row which I have to pick 7, and then 8, and then 9. So to ensure that, like, because of this constraint, now the first criteria is something you need to have the previous state for, because now that you are saying that, okay, I have to select 4 from some row, you need to ensure that you don't end up selecting more than one cell from that row. So in other words, instead of maintaining this row in sequential order, you will now maintain a list of rows that is that you have already taken or you've already considered, so that you don't consider them again, right? So in simple terms, you are changing your state from row comma taken val to val comma taken row. And why that is the case, or why that is that will help, the only reason it would help is we can't afford this, but we can afford this. And why we can afford this? Because this is like you remember this was 2 power x or x power r, right? And if you have 2 power x or 2 power r for this one, this would be better than the previous one. Why? Because the value was 100 for the left part, but it is 10 for the right part. So we'll come to that, but the overall this is our high level idea. We can't afford we can't afford maintaining the values that we have taken, so we maintain the value in the sorted order such that we don't need to maintain the list, rather maintain a single integer. But because we are maintaining a single integer, we now can't say that everything that we choose in the sorted order, because that's not always optimal. Hence we maintain a list of rows that we have already taken, and whenever we are filling up a particular value or looking for a particular value, we will avoid the rows that we have already taken before, right? So would encourage you to pause and try to write a pseudocode or do a dry run by yourself. So in the next section we'll be doing a small dry run, but again would encourage you to pause and do it by yourself at least for once. So this is how the entire algorithm will flow through. So you start with the f of 1 comma everything 0. Again, this list, either you can maintain it as a boolean list or you can maintain it as a single list as well. I just shown a boolean list, but a single list is also fine. So in this scenario, you are saying that I haven't taken any of the rows before. Everything is 0, so I haven't taken any of the rows before. Whatever you are taking, just ensure that it is greater than equals to 1. And if it is greater than equals to 1, by design, the numbers that you will pick will be unique among the previous ones, right? So again, at this state, you can either select a 1 from one of these row, right? Or you say, okay, I will not select 1 at all and I will move forward. So in that case, you will say, okay, whatever I want to select should be greater than 1, right? So again, 2 scenarios. You will not select anything which is equals to 1. In that case, you are saying that I haven't selected anything and I want, tell me what is the maximum score that I can get from these remaining rows, assuming that everything that I need to pick from now onwards is greater than equals to 2, right? Similarly, other scenario could be you pick 1 from this row, or you pick 1 from this row, or you pick 1 from this row, right? So if you pick 1 from row 2, you are saying that, okay, I have picked 1 from row 2, so 1 is there in my score. So whatever I need to select afterward should be greater than 1. So I simply increment this value to 2 so that whatever I pick from now onwards is greater than 1, which in turn would ensure that 1 never occurs afterwards. And I also marked this one as 1, which basically means I have already used the row 1 or row 2, whatever the way you index it already, so you don't use it again, right? So whatever is the value for this, again, I will simply sum it up with 1, and this is one of the possible values for this particular state. And among all possible values, I will take the maximum to get the final maximum value possible. Similarly, if you, like, there is one more state where is you select 1 from here. In that case, same thing, you have selected 1, so whatever you select should not have 1. So you simply increment the minimum value to 2, which means whatever you select should be greater than equals to 2, which in turn means that 1 will never occur. And don't use the cell or row 3 because row 3 is something I have already used, right? And finally, if you select from the row 5, this is how your state would be. Now let's just expand one more time to make things a bit more clear. So let's assume that you are trying to calculate 2 comma 0 0 1 0 0 0. So in this case, what you're trying to find is, give me what is the maximum possible value that I can achieve, such that every number that I need to pick from now onwards should be greater than or equals to 2, and I should not pick row 2 ever, or I should not pick any value in row 2 ever. So again, at this state, you will say, okay, either I will pick 2 or I will not pick 2 at all. So if I don't pick 2 at all, this is how the state would be. Basically, I'm saying that everything that I need to pick from now onwards should be greater than or equals to 3, and this is the rows that are available to me. And if I pick 2, 2 occurs here, 2 occurs here as well, and 2 occurs here as well. So either I can pick from row 1 or from row 5 or from row 4. So if I pick from row 1, this is how the state would be. I will say I will pick 2 from here, right? And I think I made it for 3, so let's assume that this is 3, okay, just for this example, but not really. So this is, if it is 3, again you have 3 at 2 different places. You have 3 at row 2, you have 3 at row 3, and you have 3 at row 4. Rest doesn't have row 3. They just doesn't have 3. So either you will pick 3 or you'll not pick 3 at all. So if you pick 3, this is, if you don't pick 3 at all, this is how your state would be. Basically, you will say pick everything starting at row 4, starting at value 4. So don't pick 3 at all. And this is all the rows that is available to you. Similarly, if the next state would be you pick 3. So if you pick 3, you can either pick it from row 2, 3, or 4. Now, row 2 is something that you can't use because that's already being used before. So there are only two possible ways, 3 and 4. So you go to 3, you say, okay, I picked 3 from here. So I added 3 to my result. Now I need to pick the rest of the row, pick some values from the rest of the rows such that everything is greater than equals to 4, which in turn means 3 will not occur anymore. And because I have used row 3, I will simply mark it 1 so that it is not used again. In the same fashion, for the row 4, you will do exact same thing, but this time mark row 4 because 4 is something you already used. Again, for this, you will have some value. So this is one of the possible values for this particular state. This is one of the possible values for this particular state. And this is another possible value. You will take max across all of this, and this will be your final value of f of 3 comma 0 1 0 0 0. And finally, you will get the values for all of these, and you will take maximum, and you will get the value for f of 1 comma 0 0 0 0 0, which is your answer, right? So if anything is not clear, strongly encourage you to rewind the past 5 to 10 minutes of the video and rewatch it so that you able to understand how we actually arrive here. After this, everything is straightforward. Arriving to the state is the best part, or rather trickiest part. So try to focus on that part by rewatching that section. So next, we'll be looking at a pseudocode. Again, there are two possible ways to code this. Either you maintain this as a raw list, or you maintain this as a Boolean array with every index as the row number, right? So if you maintain a raw list, you will maintain a list of taken rows, right? And again, to ensure that you don't compute the same state again and again, you can memorize it. And finally, inside this, what you're doing is you are iterating over every possible row which have this particular value, because that's what you are trying to fill here. So either you don't fill this at any of the rows, in that case this is how the state would be, or you will fill it at one of the rows, and you can only pick the rows which are not taken before. So you will iterate over all the rows which are not taken before, and then see which of them has the current value. If any of them has a current value, you will take that and sum it up with val plus 1 comma new taken rows, right? And you will simply this is not min, this should be max, sorry for that. So take maximum across all of them to get your final result, right? In the same fashion, you can code this entire thing with a boolean array as well, which is taken. In that case, everything will remain same. Only thing that changes is the way you are ensuring that the row is not taken before, right? So what is the time complexity of this entire approach? Number of states multiplied by what you are doing inside each of the state, because you are memorizing, so every state would be computed exactly once. So number of states would be, or rather let's figure out what we are doing inside each of the state. We are iterating over all the rows, which is order r, and then we are checking whether the current row is in the list or not, that is order r operation again. And then we are iterating over all the columns, which is order c, and then inside this we are doing some order one time operation, so that's fine. So this is the number of operations you are doing inside for each of the state. Now how many states are there? Number of different values of val, which is x, number of different values of taken rows, which is like there's a taken row is an array of size r, because you have to fill something from each of the row, and each value here could be anything between 1 and 100, right? So overall the value here would be x power, sorry, not 100, it would be 1 and r, because every value is which row is taken, so it would be anywhere between 1 and r. So the total number of states would be r power r this time. So overall complexity would be r cross r plus c multiplied by x multiplied by r power r. So this is your overall complexity. In the same fashion, if you try to figure out the complexity for this one, this is also very similar. Only thing is number of states will change. What we are doing inside of the state, this will not there, but overall it would be r cross c only. So r cross c operation for each of the state, and number of states is x multiplied by 2 power r, right? Now if you look closely, I think this one is now better, because r power r would be 10 power 10, which is worse than this particular thing for sure. So this time this one is better, and we'll choose this route to go ahead with. Again, remember in the previous one this was not better, this was better, like this version was better instead of this one. So depending on the values of r or x in the problem, one of these will be better, and you can take that route and move forward. Now just to simplify, like this will pass the given time constraint, because r and c is 10, so 10 10 2 power 10 and then 100, which is very well within the time constraint. Now to just simplify this entire thing a bit, what you can do is, instead of maintaining this boolean array, you can convert this boolean array to an integer. What you can do, because it is boolean array, you can assume that this is a binary representation of some number, some decimal number. So you can convert this entire thing to a decimal number itself. For example, in this case it would be 1 plus 4 plus 16, which is 21. So instead of maintaining this array, you can pass 21, so that this part becomes a bit more easier. Instead of maintaining a map of dp, instead of maintaining a dp as a map, you can maintain dp as a normal 2D array, because each taken is now an integer, and you can convert this integer back to its binary format to get this entire value. Similarly, this part would be 1, because there's only 1 here. So hope this entire thing is clear. If everything is clear and you watched this point, would strongly encourage you to pause and try to code this and get it accepted as well, because that's the most important part when you are solving. If you're not able to get it accepted from this point onwards, it means that something is surely missing in your understanding, and you should rewatch that section rather than looking at the code itself. So again, the motive of code, looking at the code from this point onwards, should only be how else I can code this. Not, I'm not able to code this, let me look at the code, because after this entire journey, you should be able to code that by yourself. So the code is exactly what we discussed. We simply initialize our dp array and call score of 1, 0. Again, why 0? Because this 0 basically represent everything is 0, which means the decimal representation of this entire thing would be 0, right? So we maintain this val and this mask. If we reached, I think this should be sufficient, this may not be required, and it should still pass. So if we reach at the end, we should simply return 0. Otherwise, we check whether we have computed this before or not. If we have, that's fine. If we not, we will simply first check, like there are two choices, right? Either you will take the current row, take the current value from one of the rows, or you will not take current value at all. So this is like you are not taking current value at all and moving forward. Otherwise, you can take current value from one of the cell of not used row. So this part checks whether the row is used or not. Again, you can convert this row mask to a Boolean array, but if you keep it in the integer, this is how you will check whether the particular bit is set or not. And finally, you will iterate over all the columns. If the value is equal to the given value, you can take it up and say that is one possible way to select that particular value, and this is one possible score for the current state. And you can try out all possible score, take max across all of them, and that will be your result. And yeah, I think this is executed as well. We don't need the other condition here. So hope this entire thing is clear. Any doubts, feel free to post them in the comment section below. I would be happy to answer. If you like the video, give it a thumbs up and do subscribe if you haven't already. I will see you in the next one. Thank you.